So the thing I want to show you next thing is what we call a trigonometric function. Okay, it's basically any function that has, you know, if you're familiar with sine, cosine, tangent, cotangent, secant, cosecant, you know, anything that involves this we call trigonometric function. And in trigonometric function, basically you will come across this word right here, periodic, ataupun dalam bahasa Melayu dia berkala. That means it's going to repeat. Periodic means it's repeating. Okay, for example, if I plot a sine x function, okay, the value is going to repeat. So here it's +1 here, +1 here, and it's going to be +1 again and again and again. So +1 here. So it's repeating. Okay, so this is what we call periodic. It has a period. It also repeat the same value over and over again. For example, 0 here, it repeats here at 2 pi, -2 pi, -pi, 0 pi. So this is what we call periodic. So if I want to plot such function, okay, a generic function, all right, let's say, let me see, I have some notes here, bear with me. Here we go. Okay, so basically if you have oops, what happened? Okay, basically if you have a graph here, oh, that's not nice. Okay, so let's say this is y and this is x. Okay, so let me draw it. It's not going to be too nice, but a sine function looks like that, right? Okay, it's going to continue. All right, so excuse my weird drawing here, but I really want to show you. Oh yeah, let me do this. Let's okay, let me I cannot do that. Oh man. Let's download that. Okay. Oh, I cannot save image. Oh. What I'm gonna do is this is a sine function. Okay. I'm going to upload a picture, an image. Okay. Where did I put it just now? Oh, here. All right, let's do this. Okay, so let's write on this one here. Okay, so this is from, if you pick one point here where y equals to 1, okay, and here, all right, the distance between these two, okay, this is called the period. All right, it starts 1 and it goes back to 1. You see the same shape over and over again. Okay, so that is what we call the period. Another terminology is the distance between its 0 value, or here in this case, because it's centered around 0, so the distance between here down here, this one is called amplitude. Okay, so period and amplitude. The reason I show you this function is because you are going to use this a lot in electronics engineering, in control systems engineering. When you learn about vibration, you're going to see this a lot. Okay, so let's discover this. Another thing I want to show you here is later on is something called phase shift. Okay, I'm going to go to Wolfram, but please know that I'm going to show you these three things. Okay, Wolfram. Where's my Wolfram? All right, here. All right, now usually can you tell me what the amplitude of this function right here? Can I get the voice? Tell me what is the amplitude of this here?
1.
Is it 1?
1.
1.
1,
Okay.
sir.
All right. And what about the period?
Pi.
No.
Pi.
2 pi.
2 pi.
2 pi.
Yes. 2 pi. Reason is, I know you say pi because you see here 0 here and then 0 here again, but you didn't take the count of this one. Okay, so it's 0 here to here. That's 1 period. Same thing here. 1 here. The distance between these two is 2 pi. Okay, so now how do I change the amplitude? I just put a number in front of it. 3 times sine of x. Eh? Okay, come on, it's not that hard to plot. Come on, Wolfram Alpha. Counting on you. Eh? Why does it take so long? I'm an impatient person. Ah, there you go. Alright, so if I put a number in front of that function sine x, a constant 3, I have effectively changed the amplitude. Can you see that? Yes? Alright. So that's how if you put any number here, a, so that a is going to be your amplitude. Say I put 10. Okay, you can see that the amplitude is going to change to 10. Okay, easy. Now, if I put a, let's say I put the this is back to 1, so amplitude 1, but let me put a constant in front of x here. So plot sine 2x. See what will happen. Ah, what is happening here? What changes? Let me compare. Plot sine 2x and x. Oops. Oh, okay. I forgot to put this. Hey, wait, what is it? Wait a second. Okay, yeah. So you can see this. If I plot sine x, okay, you can see the amplitude is 1, of course, but and the period is still 2 pi. What will happen if I put sine 2x? What changes? Is the amplitude changing?
Period changing.
Period changing. Okay. So if you want to change the period of a function, of a trigonometric function, you put a number in front of it. If you put 2x, well, it's gonna shorten the period. If you plot sine 1 over 2 times x, or half x, basically, half x, you are going to double the period. Okay, look at that, the yellow one. Okay, you're gonna double the period. Okay, the purplish one, purple, magenta, I don't know. Okay, that's sine x. If you put x over 2, half times x, you are effectively doubling the period. Okay, all right. So let me show you another one. This is, now we have covered amplitude, we have seen period. Now, if x is added to another, let's say add 1. If you add a number to that, what you are basically doing is you are adding what we call a phase shift. Okay, so basically let's compare this with sine x. Let me show you what is actually happening here. Okay, so for sine x, okay, this purple red is that sine x. Now if I add 1 here, I'm introducing a shift. You can imagine it like I'm shifting this red plot here backwards by amount of 1. You see? So this value right here and this here is shifted by 1 in x. Alright? I think it's easier if, let's say, minus 2. Okay, I think it's easier to see. X minus 2. I'm introducing a phase shift of 2. So this is the original sine function, red one, but I'm introducing a phase shift, x. What happened if I, oh wait, why is it, oh, I don't like this. X minus 2, I'm introducing minus 2. So what it's doing is basically it's shifting the original sine function 2 units to the right. Okay, hope you can see that. Okay, so let me, I just want to show you some example here. So okay, so basically phase shift, I think I found some good animation on showing you what phase shift is. Alright, yeah, amplitude, period, frequency. Alright, so this is a good way to look at it. So period is basically, yeah, the distance, or the x distance between two peaks or to the same value. For example, amplitude is that. Phase shift is when I shift it like that. So this is a phase shift. All right, and vertical shift, usually we don't do that. So I found this, I think this is really interesting. A will always change the amplitude. If you put a constant in front of x, for example, it will change the period. Okay, and if you add the whole thing by d, it's going to introduce a vertical shift. But vertical shift is well, not really used often. But I want to show you here, C here, phase shift. Okay, if you add a number here, it's going to shift left. That's why if I put minus there, it's shifting it to the right. So let me, I think maybe I can save this one right here. Yeah, let's remember that. Okay, let's see. I want to put it here. All right, let's add another drawing, add image. What? Cannot upload this file? Why? Looks like I have to use my hacking skills. Capture. Okay. Yes. Please include that. Yes, thank you. Let's look at this function. That's okay. So this is, I think, introducing. So if you add a number, a constant plus c, what it's basically doing, it's going to shift it left. If you add a minus constant here, minus value, it's going to shift it right. Okay, the way we test that out is always by looking at, try to plot it out. Okay, so you can see if I faced it by pi, for example, so because it's minus, it's going to shift it forward. Okay, sine x. Okay, so I'm comparing these two. So you see what's happening is basically this is the original sine function, and I'm shifting it by pi. I'm moving it forward because it's a minus here. I'm moving it forward by pi. So so you can see it's the whole sine function is shifted by a phase angle of pi. So that's what's happening. If I shift it by that, pi over 2, see, the blue function is shifted half pi. If I want to shift it backwards, I can just put plus that. Okay, so basically the original is shifted back to pi over 2. Interestingly, when I shift sine x by pi over 2, it becomes cosine function. Haha, that is interesting. Okay, so I want to reiterate here. Where's my trigonometric function? Okay, let's not use this one because you got a better. So for functions fx, a times whatever number b, okay, this is x, whatever number c, and then this whole thing is whatever number d. Okay, so it's basically doing, this one is called amplitude. Okay, all right, this will affect the period. This value right here, c, this one is called phase shift, and this will introduce vertical shift. It will move your graph further up. Okay, so what's so good about that? You're gonna use this a lot in engineering, like vibration, signals, electronics and electric control systems. You're gonna come across this a lot. Okay, and let me show you this here. There is one formula that I need you to remember. Okay, if you have a function a sine x, okay, a sine x plus b cosine x, okay, this is a function of x, function of x. So these are just coefficients. Okay, all right, f of let me see, all right, okay, this is the same as a squared plus b squared square root times sine x plus phase shift. Okay, all right. Usually this is usually in engineering, when you come across phase shift, usually it is denoted by alpha. Okay, we don't use CED here, we don't use that. Okay, so in this case it's the same thing. All right, this is what we call, this value here is amplitude, and this is what we call the phase shift. Okay, all right, so let's keep this in your notes. This is important. Okay, this is important, this is important. Okay, you're going to see this a lot when you're doing mathematics 2, engineering mathematics 2. Okay, Again, whenever I discuss about algebraic interpretation, I always show you this as well. I always show you the graph as well. So let's say I have 2 cosine x plus, let's see, 3 cosine x plus 4 sine x. Haha, sorry, that's my kid. Okay, so if you have 3 times cosine x plus 4 times sine x, is going to look like that. Okay, so let's check. Okay, I put an example here. Let's say our function is fx is 3 cosine x plus 4 sine x. So if I use that one, I can convert this into squared plus 4 squared square root sine x plus some kind of here, which I don't know. Okay, all right. Oh, I forgot. Yeah, there's another rule for this. Phase shift, alpha is inverse tangent of the coefficient of cosine and coefficient of p. Okay, so keep this in your note as well. This formula for phase shift. To find phase shifts is tangent of coefficient of oops, sorry, I got confused. P of A, B of A. Okay, that's formula for them. So that means here alpha here is tangent of 4 divided by 3. All right. Wait a second. Well, I'm kind of confused right now. A is supposed to be the value of 3 or so. No, it's not. It's 3. Okay. So A. So following that, I think it's B over 4. Sorry. 3, because it's over 4. Yeah, that's correct. Okay. So you gotta find that. So let's, if you can do this, it's 9 and 16 plus 25, so it's 5 sine x plus whatever that is. So let's calculate that first. What is tangent tangent inverse of 3 over 4? Okay, wow, 36.87. So I'm just going to take this one, 0.643. So I want to plot 5 times sine x, is it plus minus plus what was it just now? 0.6435. 6435. Okay, because according to the formula before, this is equal to this. So if I plot those together, you can see that both are the same thing. All right. So please make sure that BA. Let me make this clearer. Okay. A is a coefficient of the sine function in this case, and B is the, not a. B is the coefficient of the cosine function. I'm referring to this, yeah? This one here, B. Okay, so make sure you got this correct. Don't get confused. This one is 0.6345. Okay, so that is it for trigonometric function.